Hi, welcome to a video for Algebra 2. In this video we're going to be discussing, or we're going to be proving this identity here. So you have cosine squared x equals cosecant x times cosine x divided by tangent x plus cotangent x. So I want to prove that each of these equal each other out. So I want to manipulate the right side in particular so that it looks exactly like the left side. At least I want to prove that it does equal that. So I want to start off by looking at the more complicated aspect of this, and um, so I need to have my identities memorized in order to work this out. And I want to look first at my cosecant x. I know that cosecant x is the same thing as 1 over sine x. So for the most part, I want to make my identities into my the more commonly known trig functions sine x and cosine x. Okay, so I've done that with the numerator. I've got cosine x over sine x, or 1 over sine x times cosine x. So next I want to put my attention to the denominator, and I have tangent x plus cotangent x. So like I said before, in order to kind of mesh this together and simplify it and bring it down to make it look like cosine x, I want to make my the function that I have there right now, tangent x and cotangent x, I want to transform that into cosine or sine. Okay? And the reason why I want to do that again is because if I look on the left-hand side, I have cosine squared x. So then I want to start simplifying it to the cosines. So tangent x I know is an identity for, okay, I'm going to put my attention on that one, sine x over cosine x. And then cotangent x is the same as cosine over sine x, which is the reverse of tangent x, okay, as far as identities go. So there we go again. I have sine x and cosine x, so I know that I'm getting closer to what I want. I want it looking like cosine squared x. So I notice in the denominator I have sine x over cosine x plus cosine x over sine x. So what I would like to do is I want to bring those two terms together, and in order to put two fractions together, I know that I have to have the same denominator. So then I'll end up multiplying cosine x by sine x, and sine x multiplied by cosine x. And whatever I do to the denominator, I must do then to the numerator. Now notice what happens in the numerator here, okay? You end up having sine x squared plus cosine squared x. Let me go back just a step so you can see that happen, so you can go a little bit slower on that. Notice that the denominator is now the same. I have sine x times cosine x. It's the same. So now I can blend the numerators together. And you'll notice sine x times sine x is sine squared x. Cosine x times cosine x is cosine squared x. And that is exactly what happens. Now I can mesh those two together, and I have one fraction. Sine squared x plus cosine squared x. I know that that's an identity, and that equals 1. So now I have 1 over sine x times cosine x. So my problem is simplifying. Each step that I do, I'm simplifying and I'm inching it one step closer to my cosine squared x on the left. So let's kind of review here, or let's put our attention back to our numerator here, and let's clean this up a bit. So 1 over sine x times cosine x is the same thing as cosine x over sine x. So what I want to do, now this is dividing, so I have cosine x divided by sine x, all of that divided by 1 over sine x times cosine x. So I want to put that together. So I know that's what that means. That second line is that divided line is division. Okay, so I'm cleaning this up a bit, and I know that when I divide fractions, I want to make them into a multiplication problem, and by doing that I multiply by the reciprocal of the one on the right. And notice what happens. Okay, so now I can actually cancel some of these out, and I can cancel sine x, giving me cosine x times cosine x over 1, which is cosine squared x, the same thing. So I've just proven my original problem, which is cosine squared x, and then I've been able to prove that cosecant x times cosine x divided by tangent x plus cotangent x does in fact equal cosine squared x. Okay, well, I hope this trig problem, this identity problem helped, and good luck in your studying.